So, good conference? Excellent. Did you learn a lot of things? All right, we are going to stop that right now. We're going to have a quick session to finish out the conference, rounded off by a complete tangent. And then there's going to be a follow-up by John and Dave and Shuki, and then I think everyone's free to go. So, thanks for coming to the talk. We want to talk about languages, which is something that we both think deeply about in our lives as consultants. We work on our own. We have nothing to do with any big companies that you may have heard of. I'm Chet Haase. You can reach me on Twitter at Romangui.
And I'm Romangui, and you should avoid my Twitter. All right, so this year at I/O, there was a small announcement by Google, the Kotlin programming language. Some of us might have seen the announcement. Some of us might have even liked it. Now, Kotlin's good. It's OK. It's not the end-all, be-all of languages. So together, we've been working for years on what could be a better language. So we've come up with something that is not Kotlin. It's not the Kotlin programming language. It is not the Java programming language. It's a mix of both, plus a bunch of new features that I'm sure you will love. So,
and instead of a name, we have chosen a glyph, so that is actually the name of the language.
We are petitioning the Unicode Consortium to add that to the next set of emojis. If you want to help us, that would be much appreciated.
So we're not abandoning all the features of other languages that we've used. There are some powerful features out there. Annotation is certainly one that I think we all use and love. But maybe we could go a step further and a step better than some of the annotations we're used to. So for example, the Java programming language has the @override. This method is overriding something in the superclass. It's useful, but we find it useful for users of a language or users of a library to understand what was in the developers' heads when they were writing this library. I think it helps to get sort of a mental context of what was going on. So rather than override, we have the overridden annotation, which is not about method overriding or overloading at all. What it is actually is that the developer has objected to the following code, but was overridden by management. Some platforms have nullable or not null expressions that mean this can be null or this cannot be null. Useful, but we also find it useful to know when the developer has no idea what's going on there. In the case of the @unknown, they simply don't know what's going on there and they want to communicate that to you. In the case of the @notKnowable, it's impossible to actually determine. They spend a long time and there's actually a proof and they can show that there's no way to know what's going on in that code. I'm sure, but we've all encountered code like that. Obviously, the deprecated, it's nice to know when something goes away, but I think a more realistic thing is to know when the code is just stinks.
So one of the huge benefits of programming languages like Kotlin is they let you express yourself in a much clearer way. So for instance, here's a simple line of code that you could find in Java programming language. We just have a Boolean and it's set to true. In modern programming languages like the Swift programming language, you can use emojis to better convey your meaning. What's better success than a pile of money? But we want to go further. What if also values could be emojis? You could use the thumb down for false, but we can't stop here. How about operators? This is much clearer than equals. And also type. The yin-yang is obviously a Boolean. It is faster to read, but we decided to keep the semicolon because, we're used to it. So here's another example. I'm sure a lot of you use dependency injection, and you have to put a lot of annotations in your code. And it's much simpler now. So here we are obviously injecting a number that's the stock price. Here's the equivalent in the Java programming language.
So it's nice to have syntax in a language. Rules are good. We're engineers. We follow rules. But sometimes the syntax doesn't make sense. I'm not sure why they chose it. We, as speakers of a language, would appreciate it if a programming language obeyed more of the speaking, the written, verbal languages that we're used to. So for example, if we look at this. Well, first of all, it's important to have a name for this. At first, we called this the taxable thing, which didn't really make sense. So we'll call this syntax instead. So if you look here, you can see that there's all these semicolons there. Well, I, as a speaker in English, would never use semicolons for separating these things or ending lines. Wouldn't periods make more sense? So we'll use periods at end of lines. And to separate parameters, commas make much more sense. So we have a pause there in the for statement for int I equals 0. I less than n. It just flows more. It makes more sense. It makes it much more readable. And finally, in that last condition there, like they're saying, really is the condition, then do this other thing. Otherwise, they're very excited about the conclusion. We think exclamation points. We're really add a bang to the language.
I don't understand. So here's a topic dear to my heart, politeness. So we're all used to imperative programming languages, and in particular some of the oriented object programming languages like the Java programming language or the Kotlin programming language. One of the issues we found, and we ran a lot of studies in our lab, we realized that a large source of bugs is because we tell computers what to do. And sometimes the computers don't really agree, and the code that gets executed is not what we wanted it to be. And that's the source of most bugs, especially on Android. So we decided that it would be better to be polite with the computer. So instead of just calling a function, we have to call a function and say, please. And that guarantees that the function is executed without bugs. Now, if the function returns a value, you also have to say thank you. And if you forget to say thank you, the result is undefined. So we call this polite, this is polite object-oriented programming, or POOP.
Productivity is obviously very important to us. It's even more important to the companies that employ us. So we always look for ways to be more productive as engineers. So if we look at the data behind productivity, I think it's pretty clear that if we graph code against productivity with some nebulous units over on the y-axis over there, we can see that there's a direct relationship. If you are writing more code, you are more productive. I think we can agree on that, right? What was that big sigh out there? Okay, but you can look at it a different way. You can say there's also a relationship between productivity and code the other way, right? You see what I'm going with that? All right, but we can also see that there's a relationship between productivity and the lines of code. This is not just some nebulous quantity of code. You're actually talking about the number of lines of code, right? And again, there is a relationship between the amount of code and the lines. You see where I'm going here, okay? All right, so if you want to talk about productivity, you really need to talk about lines of code. So what we're doing in this language is we're maximizing productivity by maximizing for the lines of code. Let's look at an example here. I put a blink tag there because I want to emphasize this as one of the major points of this section of the talk. All right, so we have some code here, simple loop here. That's nice. We get a whole 3 lines of code out there, right? Well, if we're trying to maximize for productivity, wouldn't it be nice if there were more there? So what we have in the language is a mandatory line wrap at 1 column, which gives you something more like this. And that is 31 lines of code. Obviously, much more productive.
It's also why we introduced emojis, because an emoji fits in 1 character. It makes the code more readable. We're not crazy. Design by negotiation. So something that's not quite so popular these days, but it's designed by contract, where you have to install a set of preconditions or postconditions. So here I have an example of computing the square root of a number. And we said that the precondition is that the input value, x, must be greater than 0. But it's a little annoying because we have this restriction, and we have to abide by this restriction. Oh, and by the way, that code actually does compute a square root, almost. So instead, you can use the @negotiate annotation. And what it does is that it's much more flexible, because then you can call it with whatever arguments you want. Here we have an example with -1, with 3, with 2, and it's the function that decides what argument it wants to use. The result will be one of those computations. You don't know which one, but that's part of negotiations.
Actually, I'm not sure the first one there is correct. That one looks imaginary.
Yeah, but it doesn't have to pick it.
Let's talk about conditionals. So we are obviously familiar with saying if the following condition is true, do something. But we don't often know things as deterministically as that. We would find it useful if there was also a maybe clause. The maybe clause might be executed, and it might not. You just don't know. And I think that's much more realistic to how we experience our own lives. And we want the language to reflect that. We also have the sometimes clause. This is often confused with maybe, but the sometimes actually will happen occasionally, right? Maybe, you just don't know. There's no way to reason about it. Probably will happen more often than sometimes. And then finally, if you want to be more formal about your language constructs, we have the French version.
One of the new features of the Kotlin programming language is coroutines. So they're computations that can be suspended without blocking threads. And we figure that if you have a way to not block a thread, what if we had a way to always block a thread? Or always block all threads? So we introduced the strike keyword. It's what we call the union routines. When a function strikes, it always blocks the thread. But if the function is big enough, a few thousand lines of code, it will block all the threads. We can use emojis as well here. So you can use the universal symbol for strikes, the French flag. But now, of course, your execution is blocked. So how do you resume? So in your worker block, you call the function the first time, and it will block because it's on strike. So you have to call it a second time with a better argument. But it might not resume. So you have to call it another time with yet another better argument. And this time, it might resume.
There are also alternatives in the language to provide what we call scabs, which are routines that you can send in. They will do the same job, but they'll take a lot longer and probably not do it correctly. There's the DWIM, or the do what I mean method of coding. So we have some examples that I think we've probably all written errors like this before. Okay, we're passed in a value and we want to use that value in some sort of calculation. Okay, well, we may get a divide by zero error there. Or here we have an iteration, but we're actually incrementing the wrong variable in there. This is my personal favorite, is setting equal to and checking. Who hasn't done that? I want to know. All right. Liar. And then a recursive function, which never returns because you're checking it at the wrong time. So very common mistakes. DWIM is a construct in the language to actually just do what I meant instead. In the iteration case, clearly I meant I. Recurse, I probably had those in the wrong order. The equals thing, we can fix that easily. Do something, I don't know what to do. We haven't actually implemented this part of the language yet, but it is our intention to do that. We have methods in languages, so we have functions, we have methods. What we have in this language instead is a construct of methodology. It's actually a lot like methods, except we just insert a lot of sleep calls in there. Inject a lot of delay, and that must be better methodology, because you're really sort of, you're maintaining a more regular cadence of actually finishing the code.
So we did not mention that before, but our language is bringing back the line numbers from BASIC, because we find it easier to reason about the code when we can go to any line. So here's an example. We have a line that calls run foo, and it's on line 10. We can simply call go to 10, and we have a loop. Super easy. But then we add more code. We have another line, it's line 11, run bar. We can still go to one of those two lines. But what if we want to add more code in between those two? So we're in this situation. And let's say we want to go to run fast. How do you do that? We've already used 10, we've already used 11, we're stuck. Now we have to refactor our code, or worse, we have to renumber the lines. So we're introducing fractional line numbers. We round up to the nearest line. If you do not have lines between your 10 and 11, we'll jump in the middle of an existing line of code, like here. It's actually really good for code reuse, because maybe you want to call run foo, but you don't want to assign the result to a variable. You can just jump in the middle of the line to just make that call.
Floating point line numbers, it's the rational thing.
Sorry? There was a question. Okay. So here's a simple piece of code. So we have a method that returns an int, obviously. It's called getTime. We start by creating a variable of type time. It's called now. We invoke system.now. Then we call an expensive function, as noted by the little dollar bills. There's a bunch of them. Then we compute the delta of time, and we return the delta. But this function, we wrote it, it passed code review, but there's no proof that this code actually works. So in our language, every function must come with a formal mathematical proof for your code, and we use an annotation for this. And it won't compile if you don't have the annotation.
We strictly adhere to the DDD methodology, which is doc-driven development. So we all know how important documents are and documentation in code. And if anybody's read software engineering books or manuals or papers, they go based on the very reasonable assumption that the way you write any software is you write your documentation first, then you write all your tests, and then the code is simply an implementation detail. I think we all follow this, right? Okay, so we're going to take that to a better place where you write the documentation. Okay, we're going to write a method that gets a calculated value, and then we would typically write the code there. Well, why do we need to write the code? We already wrote the docs. The docs are the important part. So we're just going to infer the way that the code works. Some other examples is we may have a method that resolves complicated database dependencies. As long as we document it, we're good. It's just going to write the code and compile it for us. This one actually solves world peace, but it may return null. Speaking of documents, we have natural language comments. So it's nice that we have the ability to comment our code in these languages. I'm sure we all do it all over the place, but it's a little, like we were saying in one of the earlier points, it's unnatural. This is not the way I speak. What is this syntax here? We have a slash. We have a star over here. We have a sentence. Like, I don't speak sentences like that. So we're going to make this a little bit more natural. The comments will all be in quotes and use more natural language. Totally gives back a value, like. You can start comments with "like I mean." Another common one is, "so I says to the guy, I says."
One of the biggest challenges in programming is multi-threading. So here we have an example. We have a method that has it might be difficult for you to read in the back, but we have a variable initialized to 0. And we have 3 threads that increment that variable and call functions and pass the incremented value. But it can be really difficult to know when the value is incremented and what the value will be exactly when we call those methods. So for instance here, when I call foo of var just before incrementing it, what is the value? Is it 0? Is it something else? Because the other threads might be running, right? And locks are annoying and they're difficult and they lead to deadlock. So we don't want to deal with that. And we have the same bug all over the place. So obviously the program is not going to work correctly. So we're simplifying threading by introducing column-based programming. The beauty of this is now we can see every line of every thread side by side, so we know in exactly what order they will be executed. So for instance, when we call foo of var here, we know that var is 0 because this is the first one in the top left. Then here we know that var is 1 because in the second column it was incremented, and so on. Much easier, fewer bugs.
We also want to work on the tooling flow for developers as well. So we're going to have a system that we call auto debugging. It's going to use a binary search algorithm. So when there is a bug and it's been tracked down to a particular place in the code, then it will automatically just start commenting out bits, doing a binary search. So we can comment out that line and see what happens, and maybe a couple over there and a couple down there, and proceed along those lines until the bug is fixed. And the bug doesn't appear anymore. But the best part about this is there's no interference required on the part of the developer. It simply compiles the code, checks it, and it ships the product for you. We like GoTo. We've always preferred that as a way of writing our code, and we're sad when we didn't have line numbers and even GoTo keywords to actually use in the language, so we're obviously bringing that one back. Now, typically you would use it in a situation like this. You have some line 100, you want to go to line 250, and then down at 250, we're going to introduce the statement come from. And what this is, it's a conditional saying, I want to execute the following code only if I came from line 100, then it will do the stuff there. And if not, then else go back. So it's a way of returning. And Android developers will be happy to learn that we not only have the go back keyword, but we also have the go up keyword. Now the distinction is that go back goes to where it previously came from, whereas go up goes, no, it's, I can't remember, but they're different, they're very different. We're also introducing another methodology called PDD, or PM-driven development. You may know this in your own company situations, where PMs will say things like, our app should run faster and use less memory, or we need to increase engagement through user interaction, or we need to increase monetization by 10x. Now, these are reasonable things, and in their mind, they say, well, I've already said what the feature is. Why are the engineers taking so long to implement it when I've completely spec'd it? So what we're going to do in our language is we're actually going to let them write the code, and all they need to do is write these sentences and then put some line numbers next to them, and it's done.
And with this, we're out of time, but we have time for questions. That makes no sense.
We would be happy to field any questions on our completely reasonable proposals here. Yes? When is it going to launch is an excellent question to ask our PM.
In your proof slide, you mentioned the dollar bills for the expensive keyword. Is that something that maybe could you, what happens in different locales? Is there a get locale version of that?
Also, the question is, so we use the dollar bill to denote an expensive method call. That's not a keyword. Like, you choose, that's the way you name your variable. Obviously, if you're American, like, there are only dollars, so you can ignore the other currencies.
My favorite part of that question was that you were actually glancing down at the notes that you took. It was a nice touch.
To be clear, this is not the real product. Yes.
I trust everyone was taking notes here. Yes, in the back. So if we have multiple PMs, how do we delegate between those?
You can also use column-based programming, so you can have, each PM feature side by side.
Also, I'm not sure I'm recommending the multiple PMs approach to actually shipping products. And I should also point out that if you have multiple PMs, it wouldn't be a singular. It would actually be the PMS-driven development.
Sorry, I didn't hear the end of the question. Does it support right to left? Yes, obviously. We are open to international communities, and we want to support every locale, every language.
The easiest way to get right to left, though, is simply to turn the printout upside down.
In the back, who's first?
In what decade will Android Studio support it?
We're still negotiating with the PM of the tools team. They call the idea dumb.
It's an acronym for something. I can't remember what.
So you had a go-to line 250. What if you only have 200 lines? Do you check it at compile time, or is that fine?
Then you would fall into the do what I mean syntax, and it would just do something reasonable at this point. It would probably, maybe it would execute the line of code that was closest to 250, because that's probably what you meant, right? So.
What's the interplay between the easier multi-threading and the one-column word wrap?
I thought about that as I looked at the multi-threading on the screen, and I thought, we haven't actually made our proposal self-consistent yet. And we're still working on that one.
We think our language is a little bit like the C++ programming language, where the first AI that will take over mankind will be a correct parser for our language.
Yes?
Can you negotiate strikes?
Can you negotiate strikes? Well, I proposed the scab routine where you can send in other routines that aren't quite as good. We have in the proposal stages strike breaker routines that you can send against them to try to actually get through at the same time, but it's not working yet, and it's actually kind of gotten violent in the code. So that one's not quite ready. Negotiation, we prefer to go into arbitration. We do have a system for arbitration. It's actually still out at the lawyers. So, yeah. Yes?
So with your and auto code generation. How long have you been talking with the cucumber gherkin folks?
I lost the last part of that question entirely.
I don't understand. You're talking about vegetables, which is not the kind of stuff I like to talk about.
Gherkin, cucumber, instrument development based off of auto-generated code from actual PM.
I think you are mistaking us for programmers who know what's going on in the world of programming.
Thanks for your question. We'll follow up offline. Yes.
Do you have any features for high reliability systems like transactions or election monitoring systems?
Well, I did sort of hint at the transactional model through the document-driven development, where you could just specify what you want to happen and it'll just do it. I think that's probably the most reasonable approach, because that shit's really hard. Yes?
Does it have interoperability with any other languages?
No, because we believe that everybody should use our language.
Yes? Are we thinking of open sourcing it?
For a lot of money, yes.
That's the open source model, isn't it? I think so.
Consultants.
Yeah. All the way in the back.
Yeah, you mentioned legal. Have you thought about putting legal development?
Yes, our lawyers told us to not talk about this. The feature is there, we just can't document it or show you how it works.
And then not all the way in back.
So another function with currency symbols, does execution time change with market fluctuations?
Yes, it does. See, would you like to join us and work on this language with us?
What's your security model?
We have a guy named Bob that mans the door.
That's what I was going to say.
It's because we both know Bob.
Obviously. Sorry?
Does increased politeness reduce the likelihood of
No. We tried, didn't work.
But thank you for the question. I think the questions have wrapped up. Thanks for joining us.